And welcome back. As we go ahead and continue discussing C, let's now go ahead and segue to learning about how we can use arrays in C. So when we're discussing arrays, these are going to be very similar to what we have used in previous languages, as arrays are used to store multiple values in a single variable instead of declaring separate variables for each value. So if we want to create an array, we're going to find the data type and specify the name of the array, followed by square brackets. So if we want to insert values into it, we can use a comma separate list inside of curly braces, for example. So we can say like int numbers equals 25, 50, 75, 100. We can also specify the array size and then choose to add elements to it later. So for example, I could say int numbers equals 4, and then I could come by later and say like, int numbers of 0 equals some value, int numbers of 1 equals some more values, etc., etc. Now, what about how do we actually access those elements in the array? How does C handle them? Well, if we want to access those elements, we simply just refer to the index number. So much like in other languages, array indexes start with 0. 0 is the first element, 1 is the second element, so on and so forth. So this example right here that we're looking at would access the first element, 0 in numbers. So in numbers is again 25, 50, 75, 100. If we would print that out of numbers of 0, we would get the value 25. If we want to change an element in the array, it's really simple to do because we simply just refer back again to the index number. Like if I say numbers 0 equals 33, then this is going to change the value of number at 0 to 33. If that was 25, like we saw before, that means if I were to first print it out before the change, it'd be 25. If I then do this assignment statement, it'll then change to 33. Now, what about how to loop through an array? Because very often we need to, of course, be able to loop through an array and be able to do some kind of operation with it. Well, we can loop through with a for loop. So, for example, in this, we can look here, we have our array again set up. We have 25, 50, 75, 100 as our values. We create a variable I to act as our loop condition. So we say for I is equal to 0, I is less than 4, I plus plus. And then we can just do a print statement, which of course would print out those values. So it's again very similar to what we have seen already with many other languages and how we can handle this array. Now, one thing that we have commonly done in the past and that we might need to use for some of our applications is getting the array size. So how big is that array that we're working with? So if we want to get the size of an array, you can use the size of operator. So if you notice here in this example, if I were to use this one, I got 25, 50, 75, 100, and I were to go ahead and print out size of numbers, you'll notice there's a little note here in our comment. It says print 20. And why is that? Why is it printing 20? Well, it's because if we expect 5, there's a little caveat with how C actually handles the size of operator. C will actually return the total byte size of that array. And since an integer is, or in this case an int is 4 bytes, and we have 5 elements, using some basic math, 4 times 5, we get a value of 20. So if we want to find out how many elements are in an array, we would do the following instead of our example above. You notice it's exactly the same, except we have a new variable called int length, and we set it equal to size of numbers divided by size of numbers of 0. And the reason why we want to do this is because size of is going to get the size of this array here. But when it does size of numbers at 0, since we know that this type at this is going to give me some value, it can say, what type is this? Well, it's an integer, and then it knows to use the correct format. So this is very easily to change over to other types as well. So for example, we had a float or we had a double. We could still use the same kind of format here with the size of, and replace, of course, whatever name of array we have here is, and it would still work because, again, it's going to base it off of whatever element type is there in array of 0. So let's go ahead and apply this to make our loop from before just a little bit better. As previously saw, we can use expressions such as I is less than 4 to act as the Boolean condition when working with arrays. However, it's better to use the size of because, of course, it works for arrays of any size. So if we look here at an example, we've retooled this. And you can see now with this one, we're using the array my numbers, and you notice it's again very similar, except we have the length here that we've just looked at with that last example, and we want that length variable to now substitute in here for our Boolean expression. So now we have I is less than length, and so then when we print out my numbers instead of numbers, we should of course get the correct operation that we want, but we don't have to know what that length of that array is because we've calculated it here with a variable. And so let's just go ahead and take a look at that real quick. So here is my code. I have these a new array, which is still called numbers, but I've plugged in some different values. So I have 5230. And if we go ahead and run this, we of course will get the output 5230 because that's what this is doing. Now, if I add another element into the array, so let's just say we put in 15 and I rerun this, you see we still get that because again, it's just looping through the length of the array. And that's why it's very helpful to have a length attribute here and not necessarily a static value, because I could make this 5 and it will still run exactly the same. However, I come in here and add another number, let's just say 11, and I run that. You notice that we will not get 11 because it stopped at 5. So that again is that one of the advantages of using that variable. It will make sure it encapsulates all of those values. Now, naturally, of course, we can use this kind of feature with arrays to do other things. So, for example, if I wanted to add the different elements in an array, I can do that. So, for example, let's just create another variable. Let's just say int sum, and we'll set that equal to 0. And we can come in here and say sum is equal to sum plus, since we know what this is pulling in, it's numbers of I. And then we can just down here, we'll do a print f. And let's have this give us back our integer. And what are we going to put out? We're going to output sum. And let's just say the total is. There you go. And if we go ahead and run that, I'm actually going to move this devo first here so it's right at the proper part of that string there. Oh, looks like I forgot something here. I forgot a semicolon, very important there. Let's try rerunning that. All right, and we get the total is 36. Excellent. So again, very helpful for us to be able to do different things. And arrays, of course, are always one of those data structures that give us a lot more power with being able to work with things.